Calculus BC, we're picking right back up with lesson 6.1. We're now on part 3. And what has just happened is just revisiting our graph. We see some enclosed area here in that first and fourth quadrant. It's not really symmetrical, and that doesn't matter. But regardless, as we get this, you can see that we have now found the point of intersection is 1.80775. I'm going to store that. And for A, actually you can see I already had done that. I could restore it. It's all the same. I don't want to just round off here because there could be some round off error. And as we revisit this, you can see that x went from 0 up to this 1.187. So I'm going to integrate from 0 to A. And A was about 1.187, if I'm remembering that correctly. If we bring that right on back. Or 1.180. Sorry. So what's happening, though, is we always want to do top minus bottom. And as we're looking at this graph, we can see that the top curve was not that quartic, it was that fraction. So we can have our x all over radical x squared plus 1 minus, and then we'll have to have this subtraction of all of that quartic. The bottom part of this curve was that parabola-like shape right there. So here's the cool thing. When we're doing this on our calculator, and this is entirely a calculator problem, we could just bring up an fn int, and I'm going to say I'd like to integrate from 0 to alpha a. But really what you saw is y1 was the quartic, y2 was that other fraction. And I'm going to, instead of having to type out everything, I'll go vars, y-vars, function. We'll have our y2 right here. Now subtract vars, y-vars. We'll have y1. So I don't have to retype everything out. And you can see we get roughly about 0.785. By the way, we know that the area between two curves is positive. If we would have gotten a negative value, that would have indicated that we didn't do top minus bottom. We would have done bottom minus top. So for all of these problems in 6.1, you should get something positive. Now, one last thing, a hypothetical. What if you're asked to find the area between two curves, f and g, and unfortunately, f and g don't always have the same top and bottom boundaries. You can see they switch, and you know, perhaps f is, you know, right here. It's this curve. Sometimes f is on top, and then later on f is down below. And you can think, oh my gosh, I guess we're going to have to find an intersection, and then, you know, set up one integral and then set up a second integral where g right here would be the top boundary and then f would be down below. You could definitely do it, but look at this. Delightfully, if you could integrate the absolute value of f minus g, if you had that as a calculator problem, then you could find the area between the two curves super fast. So that's it for lesson 6.1. Good luck.